Okay, so let's try a couple of examples. This first example is from one of the slides, and it says you've randomly selected 16 coffee shops. And so our sample size is 16, which is small, and we measure the temperature of the coffee sold. The sample mean is 162 degrees with a sample standard deviation of 10. Find a confidence level of 95% for the mean temperature. Assume the temperatures are approximately normally distributed. So since n is small and sigma is unknown, we want to use T. To use T, we need degrees of freedom. So our degrees of freedom are 15. Our confidence level is 95. So let's scroll back to our table, and we're looking for degrees of freedom of 15. Confidence level of, what did we say? 95? And so that's a critical value of 2.131. 2.131. Now, the confidence interval gets filled exactly the same way. You still need to create the error, which is the critical value, times the standard deviation, divide by the square root of n, and then you're going to add and subtract your error to your sample mean. So if I've done my number crunching correctly, my error is $5.33. And since my sample mean, what am I doing? Ha 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 ha. I don't want to charge you money. We're talking about temperature. Don't listen to me. Okay, so my error is a little more than 5 degrees. And my temperature was 162. Plus or minus my error would create my confidence interval. Now what does this confidence interval mean? No pun intended there, that's bad humor, May. But what does my confidence interval mean? That I am 95% confident that my true mean falls between these two values in temperature. Okay. Now, I've pulled up the rest of the worksheet from the packet 6.1 and 6.2 to run through a couple more examples. So if you look at 3C, it says I was given a sample of 10 junior colleges to find a 98% confidence interval for the true mean. I need to assume normal distribution here in order to work this problem. So assuming on your own is probably not a good idea. If you run across anything like that in your homework, you probably should choose not to run the test. That should be one of your options in my stat lab, or email me because maybe it's a typo from the publisher. So we're going to assume normal distribution. We know n is 10. We don't know sigma. We're going to look for s. We'll look for x bar, and we need our degrees of freedom. Well, the degrees of freedom is n minus 1, so the degrees of freedom are 9. The confidence level is 0.98, and so we can go ahead and get our critical value for t before we get started. So we need degrees of freedom of 9, confidence level of 0.98. So here we are looking at our table again, degrees of freedom of 9, confidence level of 0.98. Cross those two, I'm looking at 2.821. 2.821. So we're just missing these two pieces right here. And you can calculate them by hand, but you're crazy. No one ever does statistics by hand. We always use our technology. So we need these values put into StatCrunch. So I'm going to do that for us and walk us through the steps of how to use StatCrunch one more time to find summary statistics.